In this example, we will anti-differentiate x squared over x squared minus 1. Now, looking at the form of our integrand, a quadratic over a quadratic. This is an improper rational function, so before proceeding with a partial fraction decomposition, we need to somehow algebraically rewrite. And the typical approach is to use a polynomial long division. We have x squared minus 1 divided into x squared. So we ask ourselves, x squared multiplied by what is x squared? The answer is 1, so we subtract away 1 multiplied by that x squared minus 1. And when we get this 1, that's going to be our remainder because it's degrees less than x squared. And putting this together, it tells us that x squared is equal to x squared minus 1 times 1 plus that remainder of 1. And the thing that we are hoping to work with is x squared over x squared minus 1. So if we take the x squared minus 1 on the right and divide each term by it, we will get the desired quantity. So dividing everything by x squared minus 1 leaves us with 1 plus 1 over x squared minus 1. So remember, when you use this polynomial long division, what it's going to do is take the improper rational function and write it as the sum of a polynomial and a proper rational function. So now what we need to do for this proper rational function is find its partial fraction decomposition. So 1 over x squared minus 1, that would be x plus 1 times x minus 1, is going to be equal to a over x plus 1 for the first linear term plus b over x minus 1 for the second linear term. Take the denominator on the left, multiply both sides by it. This will clear fractions. And since we are only dealing with linear terms, we can plug in intelligent choices to immediately solve for those constants. To solve for the constant a, what we're going to need to do is plug in x equals minus 1 so that the b term vanishes. So if x is equal to minus 1, 1 is equal to a times minus 2, so a is equal to minus 1/2. To solve for the b term, what we're going to do is plug in x equals 1 and make the a term vanish. So if x is equal to 1, we have 1 on the left is equal to b times 2, which tells us b is equal to positive 1/2. So let's put this all together.